Okay, in the previous video, we were discussing the basics and the introduction to what we call geometric sequences. All right, so picking up right where we left off, we know now that we can find the common ratio of a geometric sequence by dividing any two successive terms. We take the latter term, which we'll call a sub n, and we divide it by the term immediately before it, a sub n minus 1. We can express the general term, meaning any term of interest, a sub n, as the first term times the common ratio raised to the n minus 1 power, or as any given term, any previous term, a sub k, times the common ratio to the n minus k power. All right, so we don't necessarily have to have the first term if we go more generic like this green formula suggests. All right, so let's go on. Example 4 says find the eighth term. Find the eighth term. So we want, in this problem, we're looking for a sub 8. We're told it's geometric, and we are given the third term and the fifth term. So notice at no point do we have a sub 1. Instead, well, because we don't have a sub 1, I'm probably not going to be interested in using this formula here, because this formula demands that I have the first term. Instead, I could use this more generic formula and refer to any previous term as k. Well, there's a problem here. We don't have r, right? We don't know what our common ratio is because we can't just divide these two terms. These are not consecutive. These are not immediately successive terms. We're skipped one. We're missing the fourth term. So it's a little tricky here sometimes to try to find what that nth term is. But I'm going to say, what that common ratio is, r. I'm going to say if we take this formula here and we try to solve it for r, then the first thing I would do is I would divide by a sub k. So a sub n over a sub k is equal to r to the n minus k power. And now, if I were to take the root, but I can't just take the square root, I have to take the n minus k root, right? Whatever n minus k is. So if that happens to be 2, great, but if it's not, then I'm gonna use the power of whatever is supposed to be. So this is, again, n minus k root. So if I take the n minus k root of r to the n minus k, then the right side here just becomes r, and the left side is the n minus k root of a sub n over a sub k. So here's a nice little mathematical formula for finding r when you don't have two consecutive terms, when you're just given any two terms of a geometric sequence. And I can use this really immediately. I can just say, all right, well, if my third term is a sub k and my fifth term is a sub n, then I'm looking at the 5 minus 3, right? N is 5, k is 3. The 5 minus 3 root of a sub n is a sub k, a sub n is a sub 5, which is 324, over a sub k is really a sub 3, which is 36. All right, so I'm just plugging directly into this formula here that I very casually solved for r. And so that really translates into the square root, right? The square root, because 5 minus 3 is 2, of 324 over 36. And so I get an r value of 3. If you do the math there, r is 3. All right, now, I am plugging into this formula directly. The truth is, I don't know how many of you are going to take my generic green formula here, a sub n equals a sub k times r to the n minus k, and solve that algebraically for r without any values. Most people are going to, I would rather go, well, if I know these two terms, then let's just plug in. I know, let's plug in here, right? If I take my, I'll rewrite it over here. If I take my formula a sub n equals a sub k times r to the n minus k, and I just start plugging into that, then a sub n is 324, a sub k is 36, r I don't know, but I do know that n is 5 and k is 3. All right, so you get 324 equals 36 times r to the second power, really. So if you were to divide by 36, you get 9 equals r squared, and take the square root, you get r is 3. Well, guess what? That's what we just did over here. We just kind of did it using a more all-in-one power punching formula here. This formula does all of it in one step. Of course, we did it in multiple steps just so I could show you the work. But it did the same thing. You divide 324 by 36, 324 divided by 36, and then you took the square root. We took the square root and got 3. All right, so that's two different ways of showing that the common ratio here is in fact 3. So if the common ratio is 3 and I have the fifth term, then all I really have to do is multiply by 3 twice. I can take 324 and multiply by 3, and then I can take the 324 and multiply by 3 again. Actually, that would only give me 7. Then I take 323 and multiply by 3 again. Or I could use the formula. I'm going to go back up to this red formula now. Not the red formula. I'm going to use that green formula again. I'm going to say a sub 8 is equal to, a sub 8 is equal to a sub, let's use the third term, a sub 3. You can use any previous term here. A sub k is any previous term, times the common ratio r, which we know now is 3. I'm going to use that color. Yeah. Times, or raised to the 8 minus 3 power. Now notice this 3 is the numbered term I used, 3 there. And so this is 36 times 3 to the 5th power, and my 8th term, a sub 8, is 8,748. 8,748. Again, if I took 324 and I multiplied by 3, and then I multiplied by 3, and then I multiplied by 3 again, I would get here, right? Also, this stage here where I was actually answering the question, finding the 8th term, I didn't have to use the third term here. I could have used the 5th term, in which case this would have been 8 minus 5, and it would have just been 3 to the 3rd power, because 8 minus 5 is 3, instead of 3 to the 5th power. All right? A number of different ways to think about and do these problems. I'm kind of showing you an all-inclusive. Let's try another one. I'll be a little bit faster with this one. Here we're told to find the 7th term, so we want a sub 7. All right? A sub 7 is going to be some earlier term times the common ratio, some previous term times the common ratio raised to the 7th, or raised to a power. All right? So let's look at what we're given. We're given the 4th term and the 5th term. Well, that's nice and easy. If we're given the 4th and the 5th term, then all we have to do is divide a sub 5 by a sub 4, since they are right after each other, and that is negative 40 over negative 8, and we get, be careful here, negative 40 divided by negative 8 gives you a positive 5, right? So my common ratio is 5. Let me change the color on that real quick. Common ratio is 5. All right, so a sub 7 is going to be, we're going to use a sub 4, that's the earlier term we have, a sub 4, times the common ratio r, which is 5, raised to the 7 minus 4 power. Again, the numbered term is 7, that's my n, and the number of the earlier term I had was 4, so n minus k. N minus k. All right. So my previous term, negative 8, times 5 to the third power, and I get negative 1,000 out of that. So the seventh term is negative 1,000. All right. Once again, I did not have to use a sub 4. I could have used a sub 5. This could have been negative 40 right here. But that would have changed this to 7 minus 5, and I would have been squaring this 5 instead of cubing it. All right? Different ways to do the same problem. Okay. Let's talk about geometric series. A geometric series is when you add up, as we know, a series is when you add up the terms of the sequence. So if I add the terms of a geometric, that's a pretty ugly Q, geometric sequence. Add the terms of a geometric sequence, and I'm going to get a series. Remember, a series is generally represented using sigma notation, right? Usually, with some a sub n. But here, we're going to represent this with a generic formula. And our formula is S sub n. So if I wanted to add up the first n terms of a geometric sequence, I'm going to use this formula here. Notice again, this formula is pretty specific. It requires that I have a sub 1. All right. Also requires that I have the common ratio r. Okay, so let's jump into the example. It says find the indicated sum for the geometric series. They want us to find, in this example, S sub 8. All right, so automatically, this partial sum, I know I need this to be S sub 8. All right, they asked for the sum of the first 8 terms. Well, they gave us how many of them here? 1, 2, 3, 4, 5 of them. They gave us the first 5 terms. And this one's not too hard. It looks like all they're doing to get from one term to the next is multiplying by 2. All right, we know it's geometric. They have to be multiplying by the same thing. They told us that. So they're just multiplying by 2 every time. So my r value is 2. All right, so if I'm going up to this formula, S sub 8 would just be the first term, 1, that's my a sub 1, times parentheses 1 minus, the common ratio is 2, to the 8th power here, divided by 1 minus 2 again, the common ratio. All right, I'm just plugging directly into my formula for the sum of the first n terms. Again, formula says I gotta have the first term, which we have, and then I need, if I'm going for S sub 8, I need to take the common ratio to the 8th power up here, and then 1 minus the common ratio on the bottom. And this is just a matter of arithmetic, or just plug it into the calculator. Be careful when you plug this into the calculator. In fact, I'm going to show you what this looks like. You're plugging this into the calculator, you need to probably do 1 times, and then use the fraction template, which is alpha, and then the y equals button, right? Press the alpha button, and then the y equals button. And the first option is a fraction template. And the fraction template, this should be in parentheses. So open up a parentheses, then put this thing in fraction form. And when it's in fraction form, type it exactly the way it looks. Don't get cute with it. It should be 1 minus 2. I need this fraction to be a little bit bigger here. 2 caret raised to, right? The 8th power. And the bottom should just be 1 minus 2. Okay, so it should look like that. And if you plug that in correctly, you will get 255. I challenge you to test it. Try it out, plug it into your calculator, make sure you know how to put this into the calculator properly. All right, let's do another one. Example 10. Find the indicated sum of the geometric series. This one is asking us for S sub 6. Let's try the color purple on this one. S sub 6. All right, so if it's S sub 6, then my formula, if you go back up, there it is up there in red, or boxed in red. My formula says I need the first term, which is 2. All right, that's the first term here. And I'm going to multiply that by 1 minus the common ratio. All right, well, what is my common ratio? R. If you just look at this, they told us it was geometric, so I knew it was going to be, I kind of overlooked that when I started, but I knew it was going to be this formula that I use because it's a geometric series. But I did not find my R value. To go from 2 down to 1, down to a half, down to a fourth, it's clear that they are multiplying by a half every time. So my R value has to be 1/2. All right, so let's move on. That's 1 minus parentheses. Let me do this in different color. My R value was a half. So I'm going to have 1/2 as my R. 1/2 as my R here. And it is raised to they asked for the 6th partial sum, so it's raised to the 6th power. And on the bottom, 1 minus 1/2 again. So I would be careful, again, to make sure you plug this into the calculator properly. Again, use this alpha equals, get that fraction template, and be very careful. Most of the time, students are not struggling with how to plug or how to actually represent this partial sum because it's just a matter of using the formula. But students struggle with plugging this into the calculator properly, and I don't want you to do that. Of course, I will say you could do this without the formula. We have the first 4 terms. They only wanted the sum of the first 6 terms, so you would multiply by a half again, you get 1/8. Multiply by a half again, you get 1/16. And just add 2 plus 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16. That's the same as what this number is going to give you. But what it does give you is, actually it's not approximate, it's equals exactly 3.9375. If you do this on the calculator, you're going to get 3.9375. All right? Again, practice putting that in the calculator. Know what you're doing. All right? Now these were done, again, just rigorously. We're using this formula that is specific. This formula works only for geometric series. Partial sum for a geometric series. Partial, meaning finite number of terms. In this example, it was 8 terms. In this example, it was 6 terms. All right? This one is something we could, since we know how to do it, we could just plug it straight into a calculator. Right? Just use the summation option in the calculator, plug this directly in, you get 19,680. 19,680. What is that exactly? That is S sub 8. That's what it is. And so if it's S sub 8, then technically this problem could be done using this formula. But we would have to know what the first term is, and we'd have to know what the common ratio is. Right? So I could have used this formula, but that would mean I have to just dissect this summation notation here and try to figure out the sigma notation, try to figure out what is my first term, what is my common ratio. All right, again, calculator works fine if you have a problem like this, but what if you were asked to do it by hand? If you were asked to do it by hand, you'd have to start out by finding what is my first term. Well, this formula is my ith term. It's the generic formula. It's really, you could say, the same as a sub n, only they used I instead of n because they usually use an index of summation I. All right. So the first term would just be replacing the I with 1. And if I do that, I get 6. And then the second term, if I just kept going a little bit, I'd replace the I with 2, and that's 2 times 3 squared is 2 times 9, which is 18. And then the third term is 2 times 3 cubed, so 27 times 2, which is 54, and so on. All right, that same pattern continues. So what's happening every time? is they're multiplying by 3. And that's not hard to figure out, right? It's 3 that is being raised to the power every time. So the common ratio, r, is 3. All right, now I have the first term, 6, and I have my common ratio, 3, which means if I wanted, I could use the formula s sub 8 equals first term, 6, times, parentheses, 1 minus common ratio, 3, raised to the 8th power, because I want the sum of the first 8 terms, divided by 1 minus 3. 1 minus the common ratio again. Again, what am I doing? I'm using this partial sum formula here, trying to find this summation by hand instead of just using a calculator to get 19,680. All right, now if you were to do this, obviously you're jumping on a calculator anyway, because you're going to do 3 to the 8th, right? You're still kind of plugging this into a calculator, so it kind of defeats the point of doing this by hand. But nonetheless, I wanted to confirm with you that if you plug this summation into the calculator by going to math and then option 0, like we've discussed in the previous notes, you would get the same thing you would have gotten if you'd plugged this into the calculator, which is 19,680. All right, so there you have it. One last thing I want to throw on the end of these notes that is not on the regular general notes guided notes packet, and that is, what if we want to find the sum of infinite terms? The sum of infinite terms, in other words, the sum from 1 to infinity of a sub I. Again, assuming that this is geometric. It's got to be a geometric series. For geometric series, the sum of infinite terms, we'll call it s sub infinity, is equal to 1 minus, a sub 1 divided by 1 minus the common ratio. A sub 1, the first term, divided by 1 minus the common ratio. And that would give you the sum of the first of infinite terms, the sum of infinite terms for a geometric sequence, geometric series. This is, again, not in the notes, but it will show up on your MyMathLab. So I want to make sure that you know. If you're asked to find the sum of infinite terms, take the first term and divide it by 1 minus the common ratio. All right, that concludes these videos. I won't make it go any longer. We'll see you in class.